Training a single frontier AI model now burns as much electricity as a small town, and the industry is building data centers faster than the grid can feed them. Utilities are telling developers to wait years for a connection. Chips are reportedly sitting in warehouses because there is nowhere to plug them in. And even when the power shows up, a second problem hides inside every watt heat. Every computation ends as waste heat that has to go somewhere, and moving it takes enormous cooling systems, often evaporating millions of gallons of water a day in places that do not have water to spare. The AI boom turns out to be less a software story than a plumbing and electricity story, and the limits of that story are starting to bite. So faced with a shortage of power and cooling on Earth, a handful of engineers arrived at what is either the dumbest or the most obvious solution. Imaginable move the computers off the planet. Put the data center in orbit. It sounds like something you would pitch after the third coffee of a hackathon, and for decades, that is roughly where the idea lived in conference talks and concept art. But the logic underneath it is surprisingly sober, and lately it has been attracting actual startups, actual engineers and actual patents. Start with power. In the right orbit, the sun basically never sets. No night, no clouds, no winter, no atmosphere filtering the light. A solar panel up there can see the sun well over 90% of the time, and the sunlight itself is stronger than anything that reaches a rooftop down here. A ground-based solar farm is doing well if it delivers a quarter of its rated capacity across a year in orbit. The same hardware becomes close to a constant power source. And just as appealing to a data center developer, no interconnection queue, no utility to negotiate with, no substation to build, no public hearing where neighbors complain about the hum. The grid up there is one extension cord pointed at the sun. Then there is heat, and this part is counterintuitive. Space is famous for being cold. The cosmic background sits just a few degrees above absolute zero. But vacuum is also the best insulator in existence, which is why spacecraft usually struggle to get rid of heat at all. There is no air to carry it away and no water to dump it into. The only escape is radiation. Every warm object glows in the infrared, beaming its heat off into the void. Engineers normally treat that as a headache. But if you design a computer around it from day one, deep space becomes the ultimate cold sink. An infinite reservoir you can pour waste heat into forever, without warming a single river, running a single cooling tower, or evaporating a single gallon of water. That is the opening a startup called Sophia Space, working with Caltech, has walked through. Around July of 2026, they secured a patent covering a modular tile architecture for space-based data centers, and the design is quietly clever. Instead of building one big satellite and then bolting on the traditional thermal plumbing, the pumps, the coolant loops, the deployable radiator wings, you build the computer out of repeating tiles. Each tile carries its own processors, draws power directly from sunlight, and passively radiates its own heat into deep space. Sunlight in on one face, compute in the middle, heat out the other. The cooling system is not a subsystem of the satellite. The satellite is the cooling system. Passive is the load-bearing word in that sentence. No pumps to fail, no coolant to leak, no moving parts devoted to staying cool. A tile just sits there, soaking up sun on one side and glowing faintly in the infrared on the other, at a temperature its chips can tolerate. And modularity buys you the things satellite engineers lose sleep over. You can launch a handful of tiles and test them, then scale by simply adding more. If one tile dies, you have lost one tile, not the facility. The whole thing stops looking like a traditional spacecraft and starts looking like what it secretly wants to be: a server rack that happens to be falling around the Earth forever. Now for the cold water, which in this case is passively radiated into the void. Nobody is running your favorite chatbot from orbit next month or next year. The actual roadmap is far less glamorous. Small technology demonstrations, first proving a tile can compute power itself and hold its temperature in orbit. Then later in the decade, the plan is to sell components and subsystems to other satellite builders, revenue as a supplier long before revenue as a cloud provider. If orbital data centers happen at scale at all, that is a story for the 2030s. Anyone telling you otherwise is selling something, probably equity. And the obstacles are real, so let us give them their due. Launch is cheaper than it used to be, but it is still a very expensive way to ship a server. Radiation up there flips bits and slowly degrades silicon, so you either pay for hardened chips or build clever redundancy around cheap ones. When hardware fails, and it will, nobody is sliding a dead drive out of a rack. The design has to absorb failure gracefully. Latency adds a speed of light round trip to every request, fine for batch workloads, useless for anything interactive. There is debris to dodge, and every new object in orbit slightly raises the odds of creating more, and looming over everything is economics. Electricity on Earth, even scarce expensive electricity, is still radically cheaper than a kilowatt of compute delivered in space. And yet the idea refuses to die, and it is not just startups keeping it alive. Big tech executives, satellite operators, and space agencies have all mused publicly about orbital compute. Partly that is because the terrestrial constraints are genuinely tightening. Grids are congested, communities are organizing against new data centers, and water has become a political fight. Partly it is a bet that launch costs keep falling until the math stops being silly, and partly it is that some workloads are already in space. Satellites generate floods of imagery and sensor data, and processing it up there, instead of beaming every raw byte to the ground, is valuable right now at normal prices. That not cloud computing with a view is the realistic beachhead. So file orbital data centers under infrastructure futurism. Not science fiction cosplay, but not a product launch either. It is what happens when AI's appetite for energy grows so large that maybe just leaving the planet turns from a joke into a spreadsheet exercise. The physics that makes it tempting, free, constant sunlight and an infinite cold sink, is not going anywhere. The only question is whether the economics will ever stop laughing. So what do you think? Would you trust your cloud in orbit? Or is this just a fancy way to dodge Earth's power grid?